Hello guys. Actually, it took me some time to manage my work and to prepare the list of topics for the training session. Let's start. Structural steel framing. It consists of steel elements such as columns, beams, braces, purlins, girts, etc. to support the finished floor and facade of the building. This actually acts as skeleton of the building. This is a sample Tekla model of my previous job. It is added portion of a hospital building. It consists of many columns and beams. These all together called as framing. It supports the slab or finished floor of the building as well as exterior stud wall and finishing. That's why we call it as skeleton of the building. Let's look into the benefits of structural steel compared to concrete. Steel framing makes larger span without any intermediate support when compared to concrete member. It leads to more utility space on the finished floor. For concrete members, usually we need to wait for curing time of 28 days to achieve their full strength after casting. At least we need to wait for 7 days to get 70% of their full strength. But in case of steel structure, you don't need to wait for any such kind of curing time. So there is no delay in construction and it can be done in all seasons. Steel structures are easy to modify and reinforce, particularly at the stage of rehabilitation of structures. Now we will discuss about the load distribution in a building. Example, if a building consists of one level slab and framing, slab will take the live load and add up its own weight and transfers to the beams. Beams will add up their own weight and transfer the load to the columns. In the same way from column to foundation. Now if we take steel member and a concrete member which are having same load bearing capacity, steel is less in weight when compared to concrete. Thus that additional self weights of the members on foundation decreases. So foundation cost also reduces, which is an additional advantage in steel structures. Steel is durable, long lasting and recyclable. Since there is no curing time for steel unlike concrete, it is easy to meet the construction schedules. Now, what is steel detailing? Steel detailing is an engineered process of developing 3D models using different softwares with reference of contract drawings. From that 3D models, we extract part drawings, shop drawings and direction drawings for installation. Let's discuss about the workflow of the project. Here is the flowchart I have prepared to make you easy and understandable. This flowchart will get you some idea of the role of steel detailer. Firstly, there is owner. Let's say he want to build a residential apartment. Now he'll go to the licensed architect. Architect will prepare architectural plans by coordinating with the requirements of owner as well as regulations of local authority. Then owner will take those to structural engineer to develop the sizes and material grades of each structural element by load analysis and design methods. Now owner has got both the drawings, architectural drawings and structural drawings. Now owner invite for bidding to different general contractors. Once project is awarded to a general contractor, we will forward the structural and architectural drawings along with the project specifications to all the divisions involved in the building, such as joist supplier, HVAC, steel fabrication, concrete man, electrical, mechanical, plumbing. There will be an engineer of record who is called EOR to maintain the quality check at several stages of construction. He is the owner representative to check whether construction is going on as per OSHA norms and as stated in contract documents. which are project specifications, structural and architectural drawings. Steel detailer comes under fabricator. We will also receive the contract documents. We prepare 3D models using these contract documents and extract shop and direction drawings from 3D model. We will send the detailed drawings to EOR, structural engineer, architect, GC for approval first. Once we receive the approval written documents which indicates with approved as noted, then we issue the drawings for fabrication and construction. We should also coordinate with other parties before releasing for fabrication, just to avoid if any erection issues. These are the outputs from a steel detailer. 3D model with connections, fabrication drawings, erection drawings, bolt list, electronic files such as NC files and AXF files. You will get to know about these files in further sessions. Part drawings are the drawings used to prepare a single piece of steel by cutting, drilling, etc. You can see this part drawing. This is the part drawing of a plate. Here it is written as this plate part mark, plate size, which is having thickness and width. This is the plate length, grade, quantity of the plate, cross-sectional area and weight of the plate. These are the dimensions we use to fabricate the plate. Example, we'll take 6.5 by 1 feet 3 by 4 thick plate, and to punch these holes, we'll locate the holes from center of plate to 1/3 and from edge of plate to 1.5 and 9 inch. What is the hole dia? The hole dia will be 13 by 16 of 4 quantity 1, 2, 3, 4. And there is one more hole at center which is of 3 inch dia, which is located at 6 inch from the edge of plate and 1/3 by 8 from the center of plate. Thus, using these part drawings, we'll prepare the single parts. Now, what are assemblies and assembly drawings? Assembly drawings are the drawings used to prepare an assembly to fit up all the parts together by means of shop bolting and shop welding. You can see this. This is the sample assembly drawing. It consists of both main part and secondary parts. This is the main part, and these angles, this plate which is connecting to far side of the web, and these angles. These are the secondary parts of this assembly. Now all these secondary parts will be connected with reference to left extreme end of the main part in X direction, in Y direction and in Z direction. Once all these are fixed in all the 3 directions, we'll make sure these will be fit up to the main part using welding or bolting. This assembly drawing will also have a BOM in which there is a list of all the secondary parts and main parts which are involved in preparing this assembly, along with quantity, profiles, length, weight and material grades. Now multi drawings. If 2 or more assemblies are in a single sheet, then we call it as multi drawing. Example, this is a multi drawing. This multi drawing is having 4 assemblies. 106B1, B2, B3 and B4. And BOM will also be having data of all the 4 assemblies. 106B1, this is the data of 106B1, and in the same way 106B2, 106B3, 106B4. Now, you guys already know about first angle and third angle projection. These are actually part of orthographic projections. We'll get to know about these things in engineering drawings subject in our graduation. So let's discuss in brief about this first angle and third angle. In our drawings, we keep front view as the main view. In first angle projection, top view we keep at bottom of the front view, and right side view we keep to the left of the front view. In third angle projection, top view we keep to the top of front view, right side view we keep to the right of the front view. Okay, we use third angle projection in all our drawings. If you really want to know clearly about first angle and third angle projection, there is a video. I'll be sharing that video link in the description below. In that video, he has shown clearly with X-plane and Y-plane also, so that you will get to know more about this first angle and third angle projection. Okay. Now, usually in all the ASC projects, we work with FPS unit system, which is foot, pound and second. This is important for us to know these unit conversions. Also, we should be able to add and subtract the lengths in foot and inches. This scale will help you in doing that very easily. So you guys just need to remember these two conversions. 1 feet equal to 12 inch and 1 inch equal to 25.4 mm. This scale which is completely a length of 1 inch and is divided into 16 equal parts. A fabricator can measure only 1/16th of an inch distance. Below this distance he can't able to measure. That's why we divided 1 inch into 16th equal part, so that each part length will be 1/16. Now using this scale, we'll try to do some additions and subtractions. Example, see here, 3/4 plus 9/16. 9/16 means 9 parts we need to add to 3/4. So where is 3/4 here? 3/4 is this one. To this 3/4 you want to add 9 parts. 1, 2, 3, 4. When you make it to add, you have completed 1 inch already. So 1 inch you have completed. So after 4 parts, there are 5 parts left in the 9 parts. So now 1, 2, 3, 4, 5. 5/16. So the answer is 1 inch 5/16. Okay. In the same way, half an inch plus 7/16. Where is half an inch in here? This is half an inch. To that you need to add 7 parts because it is 7/16. Now 1, 2, 3, 4, 5, 6, 7. So this is 15/16. So half an inch plus 7/16 is 15/16. Now 1.5 plus 2 7/16. So keep these fractions away and these 2 inches will be added first. 3 inches, half an inch plus 7/16. So This is half an inch. To that 7 parts you need to add 1, 2, 3, 4, 5, 6, 7. 15 by 16. So the answer will be 3 inch 15 by 16. In the same way, 2 5 by 16 plus 3 3 by 16. 2 plus 3, 5 inch. 5 by 16 plus 3 by 16. 1, 2, 3. Half an inch. 5 inch 1 by 2. Now 3 11 by 16 plus 4 1 by 16. 3 plus 4 7 inch. 11 by 16 plus 1 by 16. 11 by 16 plus 1 by 16, which is 3 by 4. 3 by 4. In this way we do additions. Now we'll see how to do subtractions for the same. If you can see here, 3 by 4 minus 9 by 16. So where is 3 by 4 here? This one. Minus 9 by 16. So you need to count towards back. 1, 2, 3, 4, 5, 6, 7, 8, 9. So where we stopped? 3 by 16. So 3 by 4 minus 9 by 16 equal to 3 by 16. Half an inch minus 7 by 16. So if we go here, this is half an inch and this is 7 by 16. So how much is the gap between these two? 1. So the answer is 1 by 16. Now here 2 7 by 16 minus 1.5 inch. So what you do, make this one as round off. 2 8 by 16 minus 1 8 by 16. Half an inch means 8 by 16. So 8 by 16, 8 by 16 if we cancel, so there will be 1 inch left. 1 inch means 16 by 16. You need to decrease 1 by 16 value. So the difference is 15 by 16. In the same way, this also 3 3 by 16 minus 2 5 by 16. If you want to see clearly, you have already completed 2 inch and you have 5 by 16 left. How much you need to cross to meet 3 3 by 16? 2 5 by 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 by 16 plus 12, 13, 14. 14 by 16, which means 7 by 8. Now 4 1 by 16 minus 3 11 by 16. So from 3 11 by 16, if you need to go up to 4 1 by 16 means 1 2 3 4 5 6. 6 by 16 means 3 by 8. In this way you can able to do easily additions and subtractions using that scale. These are some important full forms that we use in steel detailing. You will get to know about this in future sessions. We'll see one by one. ABM is Advanced Bill of Material. AESS means Architecturally Exposed Structural Steel. AISC, American Institute of Steel Construction. AISI, American Iron and Steel Institute. ASTM, American Society for Testing Materials. OSHA, Occupational Safety and Health Administration. SSPC. SSPC have two full forms. One is Society for Protective Coatings or Steel Structures Painting Council. So that's all for session 1. I hope you understood and you got some idea of what is steel retailing. I'm late in uploading the first session as it takes me some time to prepare the list of topics in a row to train beginners. It also helps experienced people to brush up the technical things before starting new project while attending interviews for job switch. Next session will be uploaded in a week or early if possible. So, if you come till here, I can understand your interest in learning this. I suggest you to watch it multiple times and discuss with your mates as well. Please comment below if any doubt you have. I'll make sure to answer those all. This is your Krishna signing off. Take care.